we start section 4.3, I'm going to give you a speech that I've already given you. At the end of the semester, when the final exam comes, there is going to be all types of equations on the exam. Okay, you have to be able to recognize what kind of equation you're dealing with. Okay, is it a line, or does the equation represent a circle, or does the equation represent a parabola, or is it an exponential function or a logarithmic function? And the list goes on. Okay, so far in this class, we have studied lines and circles in depth. So I am gonna jot some stuff down up here at the top, just some reminders of what we've already seen. Okay, so we've studied lines in depth. Remember, a line is also referred to as a linear function, and the equation of a line is y equals mx plus b. Okay, so on the final exam, if you see something like y equals -3 plus 4, or sorry, -3x plus 4, you know that you're dealing with a line. Okay, now we've also studied circles in depth. Okay, if you think about a circle, any circle that you have is going to fail the vertical line test. So circles are not functions, but you still have to be able to recognize the equation of a circle and know how to work with it. So the equation of a circle in standard form is x minus h quantity squared plus y minus k quantity squared is equal to r squared. Okay, so remember we learned about, if your circle's equation is written in this format, you can identify both the center and the radius of the circle. Okay, so now we're moving on. We're going to learn a new type of function in section 4.3. We're going to be studying quadratic functions. Okay, so let me go ahead and jot this down up here. So what a quadratic function is, again, you're going to have to be able to recognize the format of its equation. You're also going to have to, know various properties about quadratic functions. So that's what this section is all about. Okay, so a quadratic function, what its equation looks like, it's going to look like this. Y equals, or remember, y is the same thing as f of x. Okay, it's going to be ax squared plus bx plus c. Okay, so a, b, and c are just numbers. X is your variable. Okay, how do you recognize a quadratic equation? How do you separate it from all these other equations that you have to know? Well, you can recognize it because the highest power of x, or whatever variable you're using, is going to be the second power. Okay, that is indicative that you're dealing with a quadratic function. Okay, what does its graph look like? Well, the graph of a quadratic equation is something called a parabola. Okay, and a parabola is a U-shaped graph. All right, so that is what we're going to be studying in this section. And actually, we're going to do section 4.5 after this, and then we're going to come back and do section 4.4. All three of these sections, 4.3, 4.5, and 4.4, deal with quadratic functions. All right, so let's get started on this section, section 4.3, quadratic functions and their properties. All right, the first bullet point on here is basically going over what I just said. It's telling you how a quadratic equation or function is defined. It says let a, b, and c be real numbers with a not equal to 0. The function y equals f of x, which is equal to a times x squared plus b times x plus c, is called a quadratic function. Okay, again, the way you're going to recognize it, the highest power of x is the second power. Okay, if you notice, there's a little condition on here. When you have ax squared plus bx plus c, those numbers a, b, and c, usually a is referring to the number in front of x squared, and then b is the number in front of x, and c is the constant. That's the standard protocol. If you notice when they define what a quadratic function is, they say a can't be 0. Okay, think about why. If a is 0, so 0 times x squared, this whole term would go away, and then you would be left with y equals a number times x plus another number. It would turn into a line, okay, if that a value were 0. Okay, so that's why they have that little condition on there. Okay, all right, moving on to the next bullet point. The graph of a quadratic function is a special type of U-shaped curve called a parabola. Okay, just like I said. So I'm going to go ahead and draw a parabola or two. So your parabola can look like this. Okay, so it's just a U-shaped graph. In this particular case, it looks like a happy face. The parabola is said to open upward. Okay, so think about it this way. If you're happy, if you've got a smiley face, you're up. Okay, happy means the same thing as up or upbeat. Okay, your parabola could also open downward. It would look like this. Okay, so think of down, frown. If you're down, or sad, you're usually frowning. Okay, and you can even make little faces out of them. How cute. Okay, so you're either going to have an upwards opening parabola or a downwards opening parabola. Okay, next term. Okay, the vertex of a parabola is its central point. Okay, so I'm going to go to these little sketches that I drew, and I'm going to indicate the vertex on each parabola. Okay, for the upwards opening parabola, the vertex is right here, that red X. So I'll even write that in here. This is the vertex. Okay, that is the central point of the parabola. Okay, so basically think of it as the halfway point. Okay, if you look at the downward opening parabola, this is going to be the vertex right there. Okay, that's the central point of the parabola, kind of the halfway point along if you were traveling along the parabola. Okay, all right, in the next bullet point, okay, we're going to talk about, like, if you are just given the equation, the quadratic equation, you're going to be able to tell without graphing it whether the parabola opens up or down. Okay, so it says the parabola f of x is equal to a times x squared plus b times x plus c opens blank if the constant a is positive. Okay, remember, when we talk about the constant a is referring to the number in front of x squared. Okay, if you are dealing with your a value, if your a value is positive, okay, the parabola is going to open upward. Okay, so in this first parabola that I drew, the upwards opening one, the a value in the equation, the number in front of x squared, is going to be positive or bigger than 0. Okay, and if you keep reading in the bullet point here, it says if you're dealing with an upward opening parabola, the vertex of the parabola is the blank point on the parabola. Okay, well, look at the vertex. Okay, it's marked with the X. If you have an upward opening parabola, the vertex is going to be the lowest or the minimum point on the parabola. Okay, so just to kind of summarize what we just said in those couple of sentences, if the number in front of x squared, the a value, if it is positive, you're going to have a parabola that opens upward. If you have an upward opening parabola, the vertex is going to be the lowest or the minimum point on the parabola. Now, on the flip side, okay, if you're dealing with a downward opening parabola, okay, let me scroll down here. Keep reading the sentence here. Okay, so I'm going to start right here. The parabola f of x is equal to a times x squared plus b times x plus c opens downward if the constant a is negative. Okay, so that's really important to know. Okay, so if we're going back up here and we're looking at the downward opening parabola, okay, we know the x is the vertex, but since it's downward opening, that means if you had the equation or the formula, the a value, the number in front of x squared, is going to be less than 0 or negative. Okay, in this case, the vertex of the parabola is going to be the highest or the maximum point on the parabola. Okay, so just to summarize again, if you are dealing with a downward opening parabola, you can recognize that from the equation. You don't have to graph it out. You can tell just by looking at the formula. If the a value, which is the number in front of x squared, is negative, you're going to be dealing with a parabola that opens downward. Okay, on a downward opening parabola, the vertex is the high point. Okay, the highest point or the maximum point. Okay, all right. Let's keep going. There's a lot of terminology associated with parabolas. Okay, in the next set of words that we're going to learn, okay, we're going to talk about the vertex more in depth, and we're going to introduce a new term called the axis of symmetry. Okay, so of course every parabola has a vertex. It's either the high point or the low point depending on whether your parabola opens or up or down, but every parabola also has something called an axis of symmetry. Okay, let's get more in detail with vertex. Okay, one of the major things we're going to learn in this section is how to graph a parabola by hand. Okay, and one of the first points you're going to end up plotting for your parabola is the vertex. Well, why? Well, because it's the central point. We need to know where to center our parabola at. Okay, so if you think about it, I'm just going to draw a sketch of the XY plane. Okay, the vertex could be anywhere in the XY plane. Okay, it's going to be some point. Okay, maybe that point in blue is the vertex of the parabola I'm graphing. Maybe my parabola looks something like this. But the point is the vertex is going to exist somewhere in the XY plane, and it's kind of the first point we're going to find in order to graph our parabola by hand. Okay, so since this point is an ordered pair, it's got an x coordinate and it's got a y coordinate. Okay, there is a vertex formula that you can use to calculate the x value and the y value of the vertex. Okay, so that's what we're going to talk about right here under the vertex and axis of symmetry of a parabola. Okay, this first bullet point says the vertex of the graph of f of x is equal to a times x squared plus b times x plus c is the point blank. Okay, well, here is the vertex formula. Okay, I'm going to write it up here and then I'll explain why I'm writing it like this. Here's the vertex formula, and you want to know this. You should memorize it. Okay, the vertex formula only gives you the x coordinate of the vertex. Okay, and we'll talk about how to get the y coordinate in just a second. Okay, this is what you need to remember. Very important for parabolas. Okay, the x value of the vertex is equal to negative b over 2a. Okay, super, super important. Okay, I'm going to put this in a red box. Okay, you have to know it. Okay, again, this is the formula to get only the x coordinate of the vertex. Okay, it doesn't give you the y coordinate. Okay, all right. So basically what's going to happen here is you're going to plug into negative b over 2a. Okay, a is the number in front of x squared, b is the number in front of x. Okay, so you're going to plug in these values and that's going to give you the x value. Okay, so then once you have the x value, and I'll write that right here, once you have the x value of the vertex, plug this x value into the original function to get the y value. Okay, so notice in this first bullet point here, I have some blanks and it's kind of set up as an ordered pair, how you get the x value and how you get the y value. So remember, if you're dealing with the x coordinate, the x coordinate is going to be negative b over 2a, but then to get the y coordinate, you're going to take that x value, negative b over 2a, and you're going to plug it in to the original function. Okay, so if we wrote it all mathy, to get the y coordinate, it is f of negative b over 2a. Okay, so if I translated that into English, you're basically taking the x coordinate of the vertex and you're plugging it into the original function. Okay, remember the original function is this. okay? And that's going to spit out the y-coordinate of the vertex, okay? And then once you know where that ordered pair is, that's where you're going to center your parabola in order to graph it, okay? All right, we will get some practice with finding the vertex when we start graphing here in a bit, okay? All right, one more piece of terminology associated with parabolas is something called the axis of symmetry. Okay, so if we read right here, it says all parabolas are symmetric with respect to a line called the axis of symmetry. Okay, so let me go back up here to the little parabolas that I drew a sketch of. Okay, I am going to draw in what the axis of symmetry would look like. Okay, the axis of symmetry is a vertical line that the parabola is symmetric about. Okay, so I'm going to write that up here. The axis of symmetry is a vertical line, meaning up and down, that the parabola is symmetric to. Okay, so if I looked at this upward opening parabola, okay, I am going to draw in the axis of symmetry. Okay, I'm just putting it as this green dotted line. Okay, it is a vertical line through the vertex. Okay, and what happens here, it divides your parabola in half. Okay, if you folded the sheet of paper along the green dotted line, the yellow side of the parabola would lie on top of the blue side. Okay, it's dividing your parabola up in half. Okay, that is what the axis of symmetry is. Okay, it is a vertical line, and I'll get more specific here, through the vertex that the parabola is symmetric to. Okay, all right, if I look at the downward opening parabola that I drew, okay, again, I would just draw a vertical line through the vertex, okay, and that is the axis of symmetry. Okay, if I drew, the axis of symmetry like this, okay, if this were an actual sheet of paper that you could fold and you folded the sheet of paper along this green dotted line, this side of the parabola would lie directly on top of this side. Okay, so that is what the axis of symmetry is. One more time, it is a vertical line through the vertex, very important, and the parabola is symmetric about that line. Okay, if we complete filling in the blank down here on this bullet point, okay, again, all parabolas are symmetric with respect to a line called the axis of symmetry. The axis of symmetry of the graph of y equals ax squared plus bx plus c is the line blank. Okay, you're going to have to identify the axis of symmetry if you are given a parabola. So you're going to have to write down what it is. And the axis of symmetry is a line. It is a vertical line. So you're going to have to write down its equation. Okay, if you think back to section 2.2 when we talked about lines, the equation of a vertical line is x equals something. Okay, so if we just kind of jotted this down, and again, this is kind of abstract because we don't have a specific example, but we'll practice this here in a second. This is what your axis of symmetry equation is going to look like. Okay, it's got to be x equals, because x equals means you're dealing with the equation of a vertical line, and it's going to be x equals the x coordinate of the vertex. Okay, this is the formula for writing down the equation of an axis of symmetry. Okay, because remember that axis of symmetry is a vertical line through the vertex. Okay, so it is nothing more, and you'll see this when we do actual examples. It's going to have the equation x equals negative b over 2a. That's just the x coordinate of the vertex. Okay, so now we're going to start talking about how to graph a quadratic equation or parabola by hand. We've got all the terminology we need, so let's take a look.